Hello and welcome to this last video in our lecture on the weaknesses of public key crypto systems. We've been discussing the public key distribution problem, and in this concluding video for the lecture, I want to emphasize how hard it is to solve this problem. And even though we discussed the use of public key certificates, just remember that if you're using those, and you are every day, you are implicitly trusting these trusted third parties, such as certificate authorities, that are issuing those certificates. And in fact, you are trusting a much bigger system called the public key infrastructure, or the PKI. So if such a PKI exists, it encompasses all of the elements that are necessary to create and use and trust those certificates. So this is not just the certificate authorities, those companies that issue the certificate, but the PKI includes everything from the encryption and hashing algorithms that are used, the digital certificates themselves, also the hardware and software that these CAs and other companies are using, the databases in which they store the information, the policies they put in place, and also, and most importantly, the people that they hired to work within that PKI. So this is indeed a lot of trust to be putting into such a big system. Because remember, a PKI is responsible for everything from the creation of the certificate, the distribution of the certificates, the management of them over time, and the storing of them, and as we're going to talk about in this video, how to renew and revoke them. So let's just remember what a certificate is. A certificate is basically a digital document that contains both a public key and the owner's ID. So the owner's ID for that public key. So the certificate puts together these two pieces of information and certifies that indeed that public key is owned by that owner by signing it, by having the certificate signed by a certificate authority that we trust. So, does such a certificate vouch for the identity of whoever sent you that certificate? So let's say you're receiving this certificate, and say from Amazon, or at least the sender claims to be Amazon. The fact that this certificate has the owner's or the Amazon's identification information, and even though it's signed by the certificate authority of Amazon's choice, can you trust that this certificate was actually sent to you by Amazon? And the answer is no. As we discussed before, you cannot know who sent you the certificate. The certificate is available to everybody who's ever done business with Amazon, since Amazon sent them the certificate. The certificate does not guarantee who sent you the certificate. What it does guarantee is that the public key inside of it is actually owned by the claimed owner. So what happens if a certificate authority actually issues a certificate to the wrong person? So the consequences obviously are pretty bad. This has happened quite a few times over the years. So I pulled up an old example from 2001 when the company, the CA called VeriSign, issued some certificates for Microsoft to the wrong person. So let me try and pull up this article here. Again, this is from 2001. You can find some more recent examples on the web. And nothing would happen is VeriSign accidentally issued two digital certificates to someone claiming to be a Microsoft representative. So in this case, VeriSign didn't do their job of checking the credentials of their user, their client, and issued a certificate to someone they shouldn't have issued them to. And notice in this case, the error is a stage 1 failure due to human behavior. So that shows that the PKI indeed includes everything from the algorithms to the hardware to the human factors and all the errors that people can make. So What are the consequences of such a forgery of a fake or wrong certificate? Well, it's actually could be pretty damaging. For example, people claiming to be someone else and grabbing your information, or in this case, it would allow them to trick users into running malicious programs, viruses, and so on. So let's say that such a incorrect certificate is issued. How long does it take to fix the problem? And the answer is quite a long time, because as long as this certificate is circulating and it's being used for malicious purposes, then it will create, or it will cause some damage. So the end of the problem is going to be whenever every single user on the internet, browser, and so on has realized that this certificate is forged and does not accept it. So you can see that it will take quite a while to solve such a mistaken certificate. So this leads us to one more property of certificate that we haven't mentioned yet, is the fact that they come with an expiration date. In fact, in the previous video, when I showed you the Amazon certificate, you can go back and check that there was an expiration date on it. So why do certificates come with an expiration date? They are not valid forever. Well, the main reason is because they may end up containing stale data. So remember that a certificate contains the owner's data, the owner of the public key, and it also contains the CA's data, the name and contact information of the certificate authority that issued the certificate. So if the certificate is valid for forever, then at some point this data might become out of date or stale, because the company's name might change, its address might change. Same for the CA information. So in general, you only want to issue a certificate for a fixed period, and therefore every certificate has an expiration date. In fact, sometimes you want to revoke a certificate before the expiration date. When would that be necessary? Well, for example, if the private key that's associated with the public key in the certificate is compromised, then you have a big problem. Because by trusting the certificate, you're actually trusting the public key, and in particular, you're trusting that the person who owns the corresponding private key is the one contained in a certificate. But if that private key has been compromised, then you can't really trust and use that certificate anymore. So as a result, one of the aspects of the PKI is to actually handle what's called a certificate revocation list, or CRL. So the CAs, once they decide to revoke a certificate, they should maintain a list of revocations. And in theory, when your browser is checking the validity of a certificate, it should not only check that it was signed by a trusted CA, but it should also check that the certificate is not on the revocation list of that CA. So in general, this is a very time-consuming process and a very complicated process. And this is one of the reasons why this idea of a PKI has not been fully implemented yet. So there are such PKIs in some smaller subsets. For example, in a particular agency of the Department of Defense, they claim to have a PKI or an infrastructure to deal with these trust issues. But in general, I want to leave you with the realization that this public key distribution problem is not only a big problem for public key cryptography, but it's really an unsolved problem.